Okay guys, this is part 4 of Matlab for summer 2020. So we are continuing our topics, and then in the previous class I started with the metrics. So if we were at the practice number 8, so we have A is 1, 4 and 5 and 6. That's right, this is a row. So and B is 0, minus 1, 0 and 1. This is another row. So if I say A multiplied by B, because they are the rows, it's gonna be an error message, because I told you when you are multiplying two rows you have to use dot star. That's right, element by element multiplication. So but if I change B to a column like this, that's right, see, this is a column. Now if I use that A by B, what you get what? A scalar number, that's right. But if I multiply the A and B, a row by column, in the previous class I told you, by this command you're gonna get a matrix. That's right. So we did that in the part 3 on the YouTube. You can go and find it. So now if I say to the part 3, here is C is how much? Minus 1, 4, minus 5, 6, 2, minus 9. That's right. And this is the columns, right? So if I say A multiplied by C, that's right, it's gonna give you error message. Why? Because the length of C is how much? 6, but the length of A is how much? 4. So you cannot multiply a row with 4 elements to a column of 6 elements. That's right. So what you're gonna do, you're gonna again do this. So what do you expect to see? Yes, a matrix, as I taught in part 3. That's right. So because A has 4 rows, so you have 1, 2, 3, 4 column here, and 6 is this. That's right. So now if I go to the part 4, as you see here, D is equal, let me see recording. I'm not talking on the air. So D is 100, minus 99, minus 55, 63, 22, and minus 8. That's right. And this is a what? This is a row. So, and the length of D, as we see, but you can do it by length command, I told you in part 3, is 6. Now if I say, if I say C multiplied by D, because C is a column, this is a row, you're gonna get what? A matrix. That's right. If I C multiplied by D again, this is a matrix. But if I say D multiplied by C, because they have the same dimensions, right? This is gonna be this time a scalar, guys. You have to be very careful. That's right. And but if I see D multiplied by C, element by element, gonna be again a matrix. So these are the linear algebra that you know it from high school. That's right. And that's it. That's right. And we explained about this. Now, as a practice at home, please go practice number 9, A, B, C, and now calculate A multiplied, I mean that element by B, A element by C, and C element by A. That's right. And I'm adding another one. So when you're doing at home, you calculate A just as this. Okay, for this problem, practice number 9. Okay, and see what's the difference between this command and this command. Okay, I'm sorry, and this command. This command, okay, and this command. Understand? So now we are done. So now After multiplying the vectors, now it's time that we go to vector dividing. Clear? For element to element dividing, we need to use this dot command. So if I say A is 1, 4, 5, 6, which is row, and the B is 0, minus 1, 0, and 1. I forgot the brackets. See, this is another row. So I can write this and this to the B. So the result is infinity. Why? Because 1 divided by 0 is infinity, 4 divided by 1 minus 1 is minus 4, 5 divided by 0 is infinity, and 6 divided by 1 is 6. Now let me see if I only write like this. I remove the dot from our operation. So what you get is 1. That's right? A divided by B. Okay? It gives you a scalar. For the other one is give you element by element dividing. That's right? So, and now look at the C. So C is for element by element, you have to do that. C is minus 1, 4, minus 5, and 0, and this is a column. So if I say A element by element to C, you're gonna get a matrix, guys. That's right? Element by element, but generates because you are multiplying a row by a column. So it gives you a matrix that is dividing this, right? So look at here. 1 minus 1 is minus 1. 1 over 4 is 0.25. Here we go. 1 divided by minus 5 is minus 0.2. 1 divided by 0, infinity. 4 divided by minus 1, minus 4. 4 divided by 4, 1. 4 divided by minus 5, minus 0.8. 4 divided by so, and so on. Okay? So, you have to be very careful of these operations, guys. Star, dot star, this means element by element multiplication. Divide, element by element multiplication. And, sorry guys, division. Dividing, that's right. So there's a distinguished difference between them. Understand? So, it's recording. Yep. Okay, guys. Now, after having the preliminary vision about the vectors, so let's move on to matrices. So we develop a matrix through the following command in Matlab. So suppose that we want to have, let me go to our PowerPoint. Okay, guys. So this is our PowerPoint. Suppose that the matrix is the very important component in engineering, guys. Okay, a very important component. Take it from mechanics of material, stress tensor, to very important in robotics, in the control, in the vibration, and in any dynamic-based analysis. So, suppose the matrix A is like as 1, 2, 3, 4, 5, 6. So you see that the vector is a subset of a matrices, right? So, and minus 2, 0, 1. Okay. So this is very important that we know how to manipulate or do operation on the matrices on the MATLAB, guys. So sticking to our notes, so this is matrix A. So A is equal to 1, 2, 4. This is the first row. Second row you have to separate with semicolon. Okay, 5, 6, 7, done. 0, minus 3, and 5. See, this gives you this matrix A. See that? This is the line that I'm talking about. Okay, so you can write the matrix in other form. Okay, means as we did in vectors. So you can put this here. It doesn't make change. So you can separate the rows element. It give you the same result. Understand? So, and now another example, this is 3 by 3 matrices, right? So guys, So if I say length of A, okay, oh sorry, length of A, this is a typo, it gives me 3 because it has 3 rows and 3 elements. Listen to this very carefully. Now let me go to let me go. We have another command that I'm gonna cover it. So B is 1, 2, 4, 6. I'm talking about this matrix. And 5, 6, 7, 4. With minus 3, 5, minus 100. This is another matrix. So this matrix has how many rows? 1, 2, 3. How many columns? 1, 2, 3, 4 columns. If I say length of B, what respect to C is gives you 4. So when you use the length command for the matrix, like vector, gives you the highest dimension of that. I mean, if you have 5 by 10 matrix, when you say length of the matrix, it's going to give you 10. If you have 100 by 2 matrix, means 100 rows and 2 columns, the length is going to be, gives you 2. For example, if you say C is equal to is 1, 1, 1, 1, 1, 1, okay, and 1, 2, and 3, and 4. No, I want to make it like this. 1, 1, yep, and 2, 2, 2, minus 3, 0, 100, 101, 200, I don't know, 1000, okay, I don't know, 55, 67, and 0 and 0. This is the matrix that you have, that's right. So if I say length of the matrix C, okay, expect to see which number? 7. Why? Because it's select, because the dimension of this matrix C is 7 by 2, has 7 rows, that's right, 7 rows and 2 columns. So gives you the largest number between the rows and columns. This is very critical, you know, okay? So matrix. This is that. But we have another command with the name of the size that I will cover it. This is very important in the coding. So my recommendation is that when you're dealing with the vectors, you use the length command. When you're dealing with the matrix, you use the size command. Okay? So, but we have many standard matrices in Matlab. Okay? Zero matrix. Let's see. Yeah. So, zero matrix. We use 0, n means number of the rows, and m number of the columns to produce a matrix with all 0 elements in n rows and n columns. So let us do that together. So try these kind of things. Look at here. So I'm saying, let me do this. So A is zeros of 2 and 2, means produce for me a matrix that has 2 by 2 elements of zeros. Here we go. 2 rows, 2 columns. If I say B is zeros of 3 and 2, means generate a matrix that has element of zeros in 3 rows and 2 columns. Here we go. Understand? And the C is zeros. This is very important when you solving differential equations. I'm going to teach you, and then based on that, I'm going to make a movie in the Matlab. Oh, Matlab is very powerful software, guys. So 7 by 7 means that generate a matrix that has 7 rows and 7 columns, and all elements are zeros. Here we go. Right? And the D is zeros of 2 and 7. Okay? 2 rows and 7 columns. See that? 2 rows and 7 columns. Okay? This is one standard. Applications, as I told you, for solving differential ordinary ODEs, means ordinary differential equations, which we will discuss later. It is clear that 0, n, and 1 generates a row vector of zeros. Obviously, see, if I say zeros of, I don't know, 20 and 1, it gives you 20 rows of the zeros, right? And 1 column. Or zeros of, I don't know, 5. Obviously it gives you 5 rows of zeros and 1 column of zeros. So identity matrix or unit matrices, right? We use I for, this I is not my I that I'm saying, this I means for identity. N and M, I put a question mark or IN to generalize the identity matrix. Note that the identity matrix is typically a square one. Applications, you're going to see for courses like ME530 that I'm going to teach, or my colleagues, robotics and so on. So let us do that. So if I say A is I and 2 and 2, here we go. This is identity matrix. Diagonal elements are 1 and non-diagonal elements are zeros. 2 by 2 matrix, that's right. And if I say B is I 3, it's going to give you the same command. So a 3 by 3 matrix, diagonal elements are 1 and this is 4. So where we are using this specifically in the, you're going to see in the control and the control and the vibration course, ME530 and ME520, when we are calculating the natural frequencies and mode shapes, because it's going to help you that you solve the eigenvalue and eigenvector problems. It's too early that you understand those, why, but I'm going to teach you how to calculate that. But we are using that unit matrix or identity matrix on those problems. Okay, eventually we're going to see. So C is I of 8, means 8 by 8 matrix. Here we go. Understand? So you have 8 diagonal elements and the others are the zeros. And the D is I. All of these has application in mechanical engineering and any engineering. So means 13 by 13. So what if I say F is I of 2 and 3? Huh? It's gonna be a bizarre form of identity matrix. It has 2 rows and 3 elements, but this is a non-square matrix. So I'm gonna talk about this if you go to grad school, ME 696 linear system theory. That is a specific form of the matrices that you are discussing there. Okay, so that's why I put, this is high level graduate course, so that I put these question marks here. Understand? So in the courses until that you graduate on the undergraduate of mechanical engineering in San Diego State, you're going to deal with the square identity matrix, okay, or I matrix. Okay, now extracting diagonal elements in a given matrix. We use diag A to extract diagonal elements of a matrix given. Like what? Like this. So clear. So A is, as I'm doing exactly like this. Here guys, this A. A is 1, 2, oh, what happened guys? Okay, A is 1, 2, 3, 5, 0, 0, 0, 0. That's right. This is second row. -4, -1, 4, 6 and 5, and 0, 4, 5, and 6. This is your, so, and as I taught you, if you use the length command, that's right, as we see, we are not blind. You see that this is a 4 by 4 matrix. So 4 equal to 4, so length gives you 4. That's right. So if I say find the diag of matrix A, this is Matlab commanding. So diagonal elements of these are 1, 0, 6, 1, 0, 6, 6. It kind of gives you 1, 0, 6, 6. This is a very powerful command in vibration, like in the courses like vibration and control. Understand? It's very interesting. So say B is another. I means identity matrix 3 by 3. If I say find for me B1 is diag of B, you're gonna see what? As I taught you right now, you're gonna see 1, 1, 1. You have to see. Understand? But if you see, I'm following the notes, guys, look at here. If the C is zeros of 4 and 4, this is square matrices, right? So here we go. Obviously, diagonal elements are zeros. So if I say C1 is diag of C, you're gonna see 4 zeros. So let me choose another. 1 divided by 1E4, 2, 3, minus 4, SQRT of 2E2 divided by SQRT of 100, and minus 100, and 0, 0, 0. This is your D. If I say find the diagonal elements of T matrix, and these commands becomes very important when you're dealing with the high degree of freedom systems, like the Baxter in my dynamic system and control lab. Okay, has each arm has the 7 degree of freedom. So as I'm going to teach you in the differential equation by Matlab, you're going to have a 14th order differential equation in state space. So you're going to have 14 by 14 matrices. Understand? So, and when it go up, and I have a dog robot or rescue robot that has 18 degrees of freedom. So it's going to has 36 by 36 matrix that you're going to deal with. So these commands are very helpful when you go to such courses. Okay. So diagonal of this is this, this, and 0. And obviously, you're going to see it here. Oh, come on. Are you recording? Yes. Good. Okay. After knowing this, and after knowing about the 0 and identity matrix, I, let's go to the next section. Flipping a matrix. We use flip all LR to flip a matrix left to right. Let's do that together. Let's see. Okay, it's very important. Okay, 1, 3. This is a matrix. This I'm talking about. And minus 4 and 6. This is the matrix, a 2 by 2 matrix. If I say A1, A underline 1 is flip LR of A. What you're gonna say, see, this 3 goes here, 1 goes there, 6 goes here, minus 4 goes there. So you are flipping from left to right. That's right. Flipping left to right. This 1 goes this, minus 4 goes this. That's right. 1 goes this, minus 4 goes this. Left to right. That's right. Understand? Or if you have matrix B as 1, 3, 6, minus 4, 6, 5, and 0, 0, 1. This is your B matrix, that's right. I forgot to bracket. So if I say B1 is flip LR and of B, what you're gonna see is this. Look at here. 1 goes to the last one here. 3 remains here. 6 goes to the place of 1. Minus 4 go to the last column. 6 is here. You are just flipping this, right? 5 goes here. Zeros goes here. 0 remains here, and 1 goes to this place. So you are flipping what? From the left to the right. So let us see if I say flip R to left. Do we have such a command? No, we don't have such a command. Guys, the battery is dying. Let me hold on and charge it. Okay, so we don't have such a command. It gives you if it says that flip left or right, we don't have it. But we do have another command, guys. Let me delete it. So if it's our B, if I say B1 is flip is up to down of B. Let me see. Here we have such a command. We are flipping from up to down. This row goes to the down row. That's right. So 1 goes to here. -4 is here. 0 goes up. Up to down. See? 3 goes here. 6 goes here. And these are goes to the first place. Understand? And this is very obvious if you add to this another row. 4, 5, and 100. See? If this is matrix, this is 4 by 3 matrix, 4 rows and 3 columns. If I say this time, see what this is, let me a little move it. So you see that? This 4, 500 goes to the first, and this third row goes to the second row. So where we are? Yeah, goes to the second row, 0, 0, 1, that's right. And this remains there, and the first row comes to the last row. That's right. This is flipping from up to down. Okay. Now, let me see. So we have time for this. So actually, I'm gonna hold it here because I'm gonna talk about this too much, because this is very important, super important property of the matrices. Okay, I'm gonna talk about this later. Okay, guys, and that's it. And I added 3 more waiting list students. So today I'm gonna send the links of all the YouTube to them. I mean that part 2, part 3, and part 4 that is today, and they can see the classes there. Part 1 is on the Blackboard, so I don't need to upload on YouTube. But part 2, and it was introduction. So, but part 2, part 3, and part 4. They can see that. I think that we're gonna have almost 30 or 25 parts, if I'm not wrong. And you're gonna be expert of the MATLAB. Okay.